we know an equation of y equals a to the power x is an exponential form equation where a is the base and x is the index or power or exponent. Also, this x is also called logarithm. So these forms of exponential form equation can also be represented in logarithm form, that is x equals something. So if the definition of logarithm is if y equals a to the power x, then x equals this x logarithm equals logarithm of this exponential base will be the base of the log a and y. That means if y equals a to the power x, this exponential form equation can be written as x, that is the exponent or logarithm, that is the power, equals log of base. Here the exponent base is a, so log's base will be a and y. So log a y, it is usually, we will tell it like this, log a base y, that is log a base y, that is the base is a and the value is y, log a base y. So if we write log 216, that means log 2 base 16. If we write log 10 1000, that means log 10 base 1000, and so on. Now, based on this definition, we will see two special case here. That is log a base a, that is if the base and the value is same, then log's value is 1. Let us prove it. If y equals ax, if y equals a to the power x, then we can write it, same thing, we can write it x equals log a base y from the definition. So now if we put x equals 1, that is if we put x equals 1 here, that means we are getting y equals a to the power 1, that means a to the power 1 means a. So from here we are getting x equals 1, so that means 1 equals log a base is there and y value, if when x is 1, then y equals a to the power x is giving y equals a, so y is also a, y is also a. So log a base a, that means if the base and value is same, then the log functions will give 1. So for example, if we have log 5 base 5, that will give 1. Similarly, if we have log 10 base 10, it will give 1, and so on. Another special case here is log any base 1, that is if the value is 1, then the log function will give us 0. So from same definition, logarithm functions definition, if we put x equals 0, here there is y equals ax, then we can write it as x equals, that is the power, logarithm equals log of this base and y. So if x equals 0, then y equals a to the power x, that means y equals a to the power 0, x is 0, so it is 1. So from here we can write then that x is 0, so 0 equals log a base, y is 1. So that means log any base 1 is giving 0. So these two relation we will be frequently using for simplification of logarithmic expressions. Here we will do 3 examples of logarithmic simplification based on the definition of logarithm function. The first one is log 3 base 81 equals what? So if we assume that this value is x, say this is x, So then log 3 base 81 equals x. We know that if y equals, if y equals a to the power x, then x equals logarithm of a base y. So x the power equals log, this exponent base become base and this y become value. So from here to here, but if we go there to here, that means from log to exponential function, here x equals log 3 base 81, log 3 base 81. So here this a value is 3, base is 3, and this value, log value y is 81. So if we convert it into exponential form, then this value, that is y, the value 81 equals a to the power x. Here base is 3, so it will be 3 to the power x. That means if we have y equals a to the power x exponential form equation, from there we can go to the log form equation by taking the power equals log of this base and this value. And if we want to go from logarithm form to exponential form, then this value y equals this base to the power this left hand side x. So here this value 81 equals this base to the power this x power. So 81 equals 3 to the power x. So from here, from log form equation to exponential form equation, we can write 81 equals 3 to the power x. So now we know how to solve this exponential form equation. So here 3 to the power x equals 81. 81 can be written as 3 to the power 4, because 3 times 3 times 3 times 3 times 3. So 3 times 3 is 9, 9 times 3 is 27, 20 times 3 is 81. So 3 to the power x equals 3 to the power 4. So x equals 4. So since we assume this value as x and x is 4, so that means this value is 4. So now let us do this one. Log 2 base 1 division 128 equals what? So we will assume it as x. So let's this one equals x. So we know now log, this is the base and this is the value. So value from logarithm to exponential, value equals base to the power right hand side x, this x, log 2 exponential, this value y equals this base and the left hand side x, here it is right hand side. So this value 1 division 128 will be 2 to the power x. So we will take base first 2, then raise the power x equals this value 1 division 128. Now we will solve this as an exponential equation. So 2 to the power x equals, if we convert 128 into exponential form, we will get 2 to the power 7. Now 2 to the power x equals 1 division 2 to the power 7 can be written as 2 to the power minus 7. So from here 2 to the power x equals 2 to the power minus 7. So we will get x equals minus 7. So here x, this logarithm value we assumed as x. So this whole value, this whole logarithm value will be x, x means minus 7. So it will be minus 7. The third one, log, here base is decimal. So log 0.5 base 0.125. Let's assume this as x. So from this logarithm function we can write the base, that is 0.5 to the power this right side x, to the power equals this value 0.125. So base to the power this variable equals this value. So logarithm function to exponential function conversion. So now we need to convert this 0.125 as some power of 0.5. So that will be 0.5 to the power x. If we apply our previous knowledge on converting decimal value into exponential or index form number, then it will be 0.5 to the power 3. So 0.5 to the power x equals 0.5 to the power 3. So x will be 3. So this value, this logarithm value is So here we saw 3 examples how we can convert a logarithmic expression into exponential form expression to get its value.